Welcome back again. Now I'm going to do the first 4 examples I did in class from 5.2. Again, these are primarily for those who were gone at the musical 5th hour on Friday. And if you were here, feel free to continue to watch. These will be a review of what we did in class, but maybe it'll help to hear me talk through them again. Okay, so the first few are going to be pretty short, so I might actually do 2 or 3 on the first video. I don't know. We'll see what happens. The first one, I'm going to call it example 1, is cosine squared x minus sine squared x equals 2 cosine squared x minus 1. Okay, I didn't really say this, but the instructions on all of these in 5.2 are going to just say verify. These are probably my favorite. This is probably my favorite section of the year. And the game, it's kind of a game, is you can't mess with the left side. So this left side has it's kind of this bubble that can't be broken. You can't mess with that. You can't move stuff into the bubble. You can't take stuff out of the bubble. So your task instead is to make the left side look like the right side. So what can we do to make that happen? Okay, so the thing I do is look to the right, and you see, it has a 2, it has a cosine squared x, and it has a 1. Look back to the right, and you see you have a cosine squared, but also a sine squared. We don't even really want the sine squared, so because there's no sine squared on the right. So I'm going to get rid of it using an identity. And you should know these. There is an identity that includes sine squared, and it is 1 minus cosine squared. And that's kind of nice because we're going to be all in with cosines, which looks a little bit like what's on the right side. So let's distribute that negative before we make any decisions about what's going to happen. And yes, that will become a plus. You probably can see what's going to happen now. The 2 cosine squareds combine, and you have 2 cosine squared minus 1. Same thing they have it here. So the way these problems should end is that something equals itself, put a check mark, and you're done. I think I'm going to go to another page here and do another problem. Hopefully it makes sense. Okay, number 2. This is another pretty short one. We'll do cosine of pi over 2 minus x over sine pi over 2 minus x. And that should equal, believe it or not, just tangent x. Looks maybe kind of strange. What's up with the pi over 2s, you might wonder, but these are those cofunction identities, the little used cofunction identities. Make sure you know them. They're quick to memorize because pretty much if you see a pi over 2, you just rewrite the cofunction. So who goes with cosine, sine? Who goes with sine, cosine? Who goes with cotangent, tangent, so on. So the numerator, when you see one of these are some of the easier ones because you just immediately rewrite it. The numerator is actually just sine of x. The denominator is just cosine of x. And recall, the right side you don't have to keep writing, but we're actually done because sine x over cosine x is simply tangent x. Done. I guess I'll go to a new video here. Hope you enjoyed part A of 5.2.
Made with Doodlecast Pro.